Hello, and welcome to OnLogic Live, Edge of Tomorrow. We're coming to you from OnLogic US headquarters to talk about the computing environment known as the Edge. While cloud computing has seen a major focus for many applications, wherein data is transferred to offsite servers for processing and analysis, edge computing is where data is collected, processed, and acted upon closer to the source. So edge computing has increasingly been seen as a valuable component of a holistic industrial automation strategy across many industries. So today we're here to talk about the past, the present, and the future of edge computing. To join the conversation, please drop your questions into the comments so we can cover them live here today. And on Twitter, use the hashtag OnLogicLive. So we're lucky enough to be welcoming two experts in the field of IoT and digital transformation to our event, Rick Lisa from Intel and Travis Cox from Inductive Automation. So first, I'd like to go ahead and introduce Rick Lisa. With over 4 decades of experience and a passionate focus on IoT and digital transformation, Rick is the Director of IoT Business Development for North America at Intel. So Rick, if you could give the folks at home a brief introduction.
Yeah, thanks a lot, Patrick. It's a pleasure to be here. Thank you for having us on. Great opportunity.
Yeah. Awesome. Well, we're really excited to have you here to bring forth your experience to talk about that past, present, and future of the edge. So thank you so much.
Yep.
Excellent. And with many successful industrial deployments under his belt as one of the first members of the inductive automation team, Travis brings a wealth of real-world knowledge around how connected software and hardware can provide value, really through a diverse set of industries, through SCADA. So Travis, could you give us all a brief introduction to inductive automation and your role within the team?
Absolutely. Yeah. Thank you for having me as well, Patrick. Happy to be here. So I work with Inductive Automation. We are a software company. We provide a industrial application platform. So it's a platform to build any kind of application. Typically, it falls in the category of HMI and SCADA. Those are the big predominant applications. But we can build MES applications, and now looking at IoT, dashboards and full kind of edge to cloud solutions, really with Ignition. I've been with Inductive Automation since the very beginning. We grew out of integration roots. So our founder was a systems integrator in Northern California and was frustrated with the software at the time in the market, couldn't find what he wanted off the shelf, and decided to build his own software company. So here we are. I serve as the co-director of sales engineering. So we focus on being a technical liaison, right, for customers to help them with their solutions and figure out best practices, architectures, and all of that. And here we are 18 years later and loving it.
That's a pretty classic story, right? Like starting out of the garage, so to speak. Someone's frustrated with what's currently out there and wants to do better. And it's a classic story. And I understand as well that you use the inductive automation software not only professionally but personally within even your own home automation.
Absolutely. I always say that we eat our own dog food, or it's a better way to say that we drink our own champagne, right? And that we use our product for everything within inductive automation, for our CRM and our timesheet management, to HR software, to our building automation software, as well as, of course, our March Madness brackets. You got to do that, right? But at home, I use it for my home automation system, and it's a lot of fun to be able to take the same platform that I work with there and bring it here and provide some cool value at home.
Yeah, absolutely. And I think for many people, if you're trying to understand really where does the value come from sensors, the ability to automate processes, think of home automation, and you start to see those efficiencies stack up really quickly. And applying those same approaches within your business gives that same level of efficiency, time savings, thereby cost savings. So just really excited to jump right in. And you've had quite a tenure there, 18 years. Now, I guess to lay some groundwork, how have you seen edge computing evolve from those early days? And what value have you seen it provide to production facilities in the real world?
Yeah, so when you look at SCADA, look at how we historically have built SCADA systems. We would deploy a central server, and we would then connect that directly to all of the intelligent devices, or PLCs, that are out in the network. And we would do the pull response protocols to get that data, right? Pull that information every second, bring that information back up to a centralized control system. Well, that inherently has some issues, especially when we look at industries where the communication is kind of shaky. Take a look at water, wastewater as an example, where you've got booster pumps out there over cellular, over satellite, or microwave, and if we were pulling those devices over that communication network that happens to go down, then we would lose information, right? So the edge became really important to be able to deploy a part of the stack at the edge of the network to be able to give us that functionality, like store and forward, to cache that data locally, then forward it back up to our centralized system, or to provide a local HMI, right? If you classically, an HMI is kind of always been edge, right? It's right there talking to those devices, giving you that critical control system. So the edge has been able to provide us, that local customers' local functionality where they have some real world, network or, concerns that are out there to help really facilitate a better, larger SCADA system at the end of the day. But we look at today, it's not so much communications issues, and bandwidth issues. It's really, we want to get at more of that data. And in order to do that, edge becomes really important, right? We have to be able to pull that information really locally at faster rates. We want to get more data, and we want to efficiently bring that data up to our enterprise.
Yeah, I mean, data means actionable, right? Data means you have those points at which you can see the information that's coming in. You can see how everything is performing. You can also start to look at predictive maintenance and watching for those times where that data gets out of spec, and you're able to say, okay, we need to approach this before it causes any real more major failure or issue with production, or two, a safety as well, keeping the people on the ground safe who are working around the machinery.
Absolutely.
Yeah. And so there's really this conception though, like when people are getting started, it sounds really good. It's like, I want that data. I want to be able to understand it. I want to be able to have that predictive maintenance. I want to be able to have that eagle eye view of my facility. But there's a conception out there that upgrading your facility to a smart facility, via such a solution would require a lot of like costly rip and replace, as it's known. So just pulling a lot of devices and machinery that's legacy and having to replace with all new. So I would be curious for Rick and Travis, how do edge devices potentially help to upgrade those systems and those facilities without needing that step of rip and replace and that loss of investment?
Yeah, I think as Travis said, the history has largely been around sort of a process control, process automation dynamic. Using industrial PC and industrial server technology more as control and automation appliances at the edge. But as it grows up, and as it grows out of sort of this appliance and control environment into this, more of an edge compute technology, what we're starting to see is more cloud-like capabilities and more data center-like capabilities being deployed at the edge. So the machine learning, the analytics, you mentioned predictive, kinds of maintenance activities, but what we're actually seeing is a move toward more digital twins and prescriptive kinds of environments where the systems are self-healing. So we're actually starting to see the business and the opportunity grow beyond basic control automation to more of a data processing type environment. And as that happens, what you're doing is you're taking commercial off-the-shelf industrial PC and industrial server technology, and you're just growing it to the next level. And as the computing becomes more capable, it doesn't necessarily require that I have to rip out old equipment to put in new equipment. The old equipment, we're able to use tools that are available in the industry today to talk the industrial protocols, to talk to the current means of data migration and data communications, but then apply these new higher levels of compute technology. So what you're actually doing is seamlessly growing the compute complex on top of the existing infrastructure. You're not actually having to replace the existing infrastructure to get all new capabilities. And this is a pretty seamless approach to the current deployed technologies that bring all new functionalities to the local environment, and actually a seamless integration to the more, as Travis referred to, the centralized or core enterprise compute resources of the company, whether they be on-prem or off-prem.
Yeah, when we look at digital transformation journey a lot of customers have been on. The worlds of OT and IT have kind of always been, if you will, they're different worlds, right? They haven't really come together so much. But today, the demand of the data, the wanting to do more with that data, as Rick was talking about, that it becomes really important that these worlds come together and work together really nicely. You've had companies where they have their SCADA solutions that have a lot of that data. I mean, we have a tremendous amount of data on the OT side, and ultimately they've tried to turn SCADA into middleware, or figure out through scripting or adding other pieces on top of it how we can get that data to the business side or to the cloud, and it makes that OT system kind of brittle, right? We don't really want to do that, and the operational folks don't want to do that because they don't want to disrupt their operations. And so the idea is really not to disrupt anything or rip and replace. It's to be able to introduce technologies that fundamentally can look at the data, from an edge first standpoint, single source of truth, that leverage today's modern open standard technologies that allow us to get that data up to the business side, to the cloud, where securely and efficiently, where we can really take advantage of that data. And there's really great cost-effective solutions that we could do that and have them in parallel with the existing systems. Ultimately, we can get to a much better architecture on the OT side of the fence, right? Rather than classically connecting our applications to devices, we can get to a more decoupled approach, and we could do that slowly, though, right? Where we can have our devices being the ones that are publishing the information up, and then where we could take advantage of that. And protocols like MQTT and various open technologies allow us to do that. And there's just tremendous value and benefits that we can get from it.
Yeah, I think as Travis said, I think there's this, the OT world of old was a proprietary, closed environment, where the IT environment was a much more open, standardized environment that was pretty common. But what's happening is the computing environments on the edge become more and more IT-like, while they retain many of their OT underpinnings. The ability to actually seamlessly merge these two environments is growing tremendously. And as the compute complex, the networking environment, all new 5G technology, these don't have to be deployed as disruptive technologies. They can be seamlessly married into the current environment.
Yeah, and some of those pieces as well. So to the point that Travis, you made around being able to do some of that processing locally, and then using a protocol like MQTT to send more lean data, up to the cloud, it gives you kind of the best of both worlds, where you're able to say, we want that processing to happen locally, but we want those deeper insights potentially to move up to the cloud, for storage, for visibility off premises. But you get to choose, what that data is that really goes on and off premises. And also it's worth noting that when you do have a piece of hardware that's, in an industrial setting or within a manufacturing setting, wastewater management, it helps to make sure that you're right sizing that hardware and you have the right technologies behind it. And so I would be curious, Rick, what is that right mix of, hardware? From that hardware perspective, what technologies, such as, within the systems that OnLogic makes, what are some of those technologies that can benefit an edge computing application?
So I think when we start looking at the technologies that are going to get adopted in this edge environment, one, they look very similar to what's already deployed in the IT environment. But I think that there's going to be a greater dependence on higher bandwidth networks. So I think as we look at the evolution of 5G as a technology, you're going to see that become a greater and greater piece of the equation. I think scalable compute is important. The ability to right size, as you said, the computing complex for the size of the workload to be, managed. So the ability to seamlessly scale from a small compute footprint to a larger compute footprint that then can actually scale seamlessly to a multi-processor or multi-platform environment. It's interesting to me as I work with companies, but it's always interesting when the company says there's this one problem I want to solve. But then once you solve that one problem, they have 3 more, and then 5 more, and then 10 more. And the demand for the services and the applications that are required at the edge, together with those in the centralized core of the company, they endlessly grow. And so the complex has to be able to start at a point and grow out. And that's why that scalable compute capability that has sort of unlimited ability to grow and take on capacity is important. Artificial intelligence, machine learning, again, building that sort of digital twin of the environment, right? The ability to actually take an analog environment and then represent it digitally in an environment for compare and contrast between, the ideal world, so to speak, and the real world, but then use that data in order to be able to advance, essentially preventative, predictive, and prescriptive self-healing, type of technologies that then augment worker experiences. So the ability to essentially model the real world against the digital world, I think, is going to be another important part of this. The amount of data we're going to move is going to drive the need for data compression and data management, device management, being able to provision, support, and maintain all these different connected devices. As you look at these different activities, users' rights management, digital rights, access controls, and security. If we can't trust the environment, there's no way we can actually execute that environment reliably. And moreover, it's not only security within in terms of access control and rights, but it's also cyber threat externally, as we've seen recently with a lot of things in the news. So there is actually quite a bit of technology that we're going to be deploying at the edge that hasn't been considered up to this point, but it really does change the dynamic, pretty significantly as we go forward.
Yeah, when we look at the OT systems that we have, right now it's incredibly important to be able to kind of fix the architecture. Get away from the coupled approach where we have applications talking directly to these devices. We want to get to a place where we can have the devices publishing data into infrastructure that we can leverage, right? Having this be open standards I mentioned before, but doing it in a way that also provides all the context you need. It provides, we know what the engineering units are. We know what asset or model that it is. We know, everything about that, so that can be discovered at higher layers. I mean, it's going to assist in that digital twin that Rick was talking about. But we want to be able to, get to a place where we can have all the data at the edge, a lot more of it being published up, and where we ultimately can take advantage of it, but have superior OT solutions. We have to look at it from an OT first mindset, fix the architectures, then it becomes really approachable to start looking at the next steps, right? What the future can look like. And I think that's where, selecting the right edge computer at the beginning that has, the ability for you not only to solve the challenges that are needed right now, but that can solve challenges that are coming up in the future.
Yeah, to add on top of what Travis just said, I think, one of the things we got to keep in mind that, we talk about these compute domains as though they're separate areas, right? That, the edge is somehow different from the core, somehow different from the cloud. It's not. These need to be a seamless compute continuum. It has to be serving the needs of the enterprise across all of its operations, not only its facilities, its premises, if you will, but the products and services that they build, that they deploy to their customers, to the processes that they run within the company, and people integration that goes with that. So when Intel kind of approaches these engagements with companies, we actually work with them across what we call the 4 Ps, right? The processes, the premises, the people, and the products. And what we're really looking to do is look at the seamless integration of IT equipment as a backbone to that whole flow as a compute continuum, not as islands of compute. And so this is an architectural approach, to Travis's point, that we really have to be able to help companies navigate, so that what they're not doing is deploying POCs that become pilot purgatory type of events, but that what we're getting to is something that actually is delivering benefit across the continuum of the entire corporation.
Yeah, it's really where the OT managers, the IT managers are really fundamentally working together to solve the challenges that the business requires, right? There's not just looking at their own domain by itself, because that's not how it is anymore. Everything's very much connected, edge to cloud. And there's a tremendous, benefit we're going to get from accessing and learning more about our data, but we have to, I think there's more of a people resistant to this, more of a political, thing that's needed here in order to get that acceptance across the board that this is something that we need to do.
Yeah, and starting from the right place and getting that data to start flowing. If we are talking about someone new here, we went into kind of the deep end here, and we're going to be going into the future in just a moment. But if you're looking for that solution today, and perhaps you've been challenged, to combine as an IT and an OT team to start getting that data up in a traditional setting, brownfield as they're often called, then having that proof of concept, making sure that you have that right device to connect in, it has the right IO, it has the right capabilities, it has the expansion needed to be able to scale to that next step is incredibly important. And that's why, like from a consultancy standpoint, you want to make sure that you're providing that industrial computer that actually has the connections that are needed, so that data can start flowing now, prove that value early, and then that can really inform through those learnings, what that next step is, and how you want to expand from there. And to speak to that and to speak to expansion and the future of edge computing, we talked a bit, and Rick, you spoke around digital twin, that idea of that self-healing reflection of your factory within the digital realm. But when we were chatting prior, we were talking about, well, where do we start if we're wanting to head towards digital twin? And we started to talk about the concept of a digital mirror as a great starting point. So Travis, I was hoping you could introduce the concept of that digital mirror and how it can really benefit people as they're looking future forward.
Yeah, so I mean, as we look to the future, we'll talk probably more about machine learning analytics and some of the possibilities that are there. But fundamentally, in order to approach that, we have to be looking at our data in the right context, right? We have models and we have assets out there that we not only do we need from our operational technologies, but we need to know those same assets and models when we're dealing with the cloud, as an example. The digital mirror idea is basically to say, look, we need to be able to define that model at the edge with all of its context, with all the information that we have. It's one place through that mapping, have that being published up that is automatically discoverable at every layer, including the cloud, so that we're looking across the enterprise, we're seeing assets that are like assets that we can then do correlations on, that we can run algorithms on, that we can go further with. If we don't have that standardization, it becomes really difficult to start getting into some of these higher level functions. So the idea of the digital mirror is to basically be able to provide across the board, be able to provide all the data that we have with the right information and context that allows us, to go a lot further. And that really comes down to defining those models, defining those assets that we can be working with.
Excellent. And Rick, to take that from that concept of digital mirror, which is that reflection of your facility within the digital realm, and take it into that realm of digital twin with AI and really self-healing. Could you introduce us to the idea of digital twin and what you foresee that ultimately providing to facilities in the future?
Yeah, I think when you look at the evolution, digital mirror, digital twin, there's differences, but there's also a lot of similarities between those two things. I think when you get to digital twin, though, what you're really getting to is, how do you get out of the modeling and the duplication of it, but into the execution of the environment. And so I think, as we evolve past, preventative and predictive maintenance, we get to prescriptive, but then we get to these ideas of, worker augmentation. We actually start to build, instead of HMI meaning human machine interface, it's going to mean human machine interactions. It's how do you start actually putting the machine and the human engagement together simultaneously and seamlessly. But I think where we actually see it going is as we begin to trust machine execution more and more and more, it leads to autonomous systems where it goes beyond sort of self-healing and self-prescribing. It goes to a fully autonomous executing environment. We're seeing that today in some areas. Not only are we seeing it in manufacturing, but we're also seeing it in smart building technology. Where, frankly, we have one example, interestingly enough, where when the people walked out of a building a couple of years ago to go see the eclipse that was happening, a building actually in New York was able to actually go through and adjust all of its electrical patterns, all of its air conditioning activities and technologies internally, and it did it all autonomously. The building did it itself. It recognized that 1,000 people walked out of the building, and the building just adjusted. I think we're going to get to that level where when you're that confident in what the twin is telling you about the execution world, you let the machine do the work. But we always have the ultimate control back in the human-machine interaction, and I think that's where it's going to lead over time.
Oh, that is fascinating. The idea of that number of people leaving the building and it knowing in real time, and that was not a long event either. That was a relatively short event. I remember being out looking at it in the parking lot, and it was able to adjust, potentially even like saving energy, saving energy, saving costs,
That's right.
and moving from that place of like just data and information into a place of really what I'd start to describe as knowledge that you can act upon. So that was a fantastic example, and thank you so much.
I think from that example, it all happened within minutes. It wasn't that it took an hour for the building to adjust. It happened within minutes, right? So there is a lot of capability here, and I think industry needs to start tapping into that capability, but it does take growth in skill sets and workforce capabilities that companies need to start planning for today.
Absolutely. And with that, I think we're in a great place to switch over some questions. So we're going to start with a few here that we've had in the lead up to the session today. But for those of you who are watching live, there's still time for you to chat your questions in, really tap into this knowledge base that we have with us today, and cover them in the moment. So first question that's popping up here, are there any common mistakes that should be avoided early on when thinking about project requirements? What usually gets in the way of scaling later on? So essentially, are there early mistakes that you can make when you're speccing out your project that should be avoided from your knowledge that you've seen in the real world?
Yeah, I think a big one right away is thinking too small. Again, you really have to think about the enterprise impact of what you're doing and what the enterprise value is. I mentioned the idea, and I think Travis used it as we were talking before the event here, this idea of pilot purgatory, where you get into these little tiny projects that have small impact, but then there's no corporate investment. There's no way to tie it back to the greater purpose of the company. So I think what you got to think about is as you're building out these programs, don't silo activities off. Think about it holistically and how you want to affect the entire company. Come back again to that 4Ps concept of processes, premises, people, and products, how you integrate across those domains. And then the project has relevance into the investment picture of the company. It's not just a project or a program that's siloed and sequestered away, but something that actually is going to have impact to the business.
Yeah, absolutely. You said that really, really well. I mean, that is something that a lot of has been a lot of issues for companies, getting started. I think another thing too I look at is putting the right solutions in place. I mean, we talked about hardware, right? Putting the right type of hardware in place at the edge. It's going to help us solve not only challenges now, but into the future. A lot of times we see it, right? We just want to put the bare minimum of what we need to put out there. It's going to solve our challenges, but it's not going to let us grow and scale. And scalability is incredibly important here as we look to the solutions. Plus, we also have to have solutions that are very transparent, kind of leveraging open technologies that we understand, that don't potentially lock us into a proprietary technology or a vendor. We want to be able to access different technologies and have the interoperability that's there, along with being able to go the next step, like we've been talking about here. So thinking holistically and kind of really putting in the right solutions, is at the beginning is going to be a really big step forward.
Yeah, and that is something that we speak to at OnLogic all the time. Is, are you choosing what the bare minimum, to your point, Travis, that you need for today, or are you really thinking that you're building something? You want that thing to continue to move forward, to scale, And so working in that kind of consultative manner between partners as well, between ourselves, Intel, and inductive automation, we're able to have that vision over what do you need and where are you going, and be able to consult and make sure that you're getting that proper hardware to start off with, and you're getting those proper technologies within it. Yeah. So it looks like we have our first question live from LinkedIn from Leonard. Any one of your products integrate with NetSuite? So Travis,
I could start there. Yeah, I mean, so with our product with Ignition, we have a lot of integration. We like to call it data kind of a communications hub to a lot of different pieces, right? Not only does it have drivers to all different PLCs that we have out there, leveraging protocols like MQTT and OPC-UA to get access to more data or to publish that data into an open format. But when you look at different products, there's different kind of integrations that are there, between like REST and SOAP APIs that exist, or communication to databases, where database is kind of the middle. A lot of the integrations happen through one of these kind of standard mechanisms that we're looking at. In some cases, there might be some direct integrations, but more often it's based on these open APIs or open standards that we're looking at.
Yeah, I think I would just add to what Travis said is that, not only is, and I think the root of what he was saying is that data migration into tool sets that run on separate clouds or under separate compute environments is part of what we're talking about when we refer to this seamless environment. The problem is one of data migration and data preparation, data normalization. So once I've collected data, unstructured data at the end, I've turned it into structured data in some sort of repository, moving it into a tool set like NetSuite or into any cloud-based, business application or again, leveraging that data across multiple tools or multiple application suites becomes possible. And that's what we talk about as seamless compute continuum. If you really, again, going back to the problem of starting too small, if you're not thinking about the tools at the enterprise level that you want to marry together with the tools, at the edge domain and deep into the edge in terms of right down at the equipment and the tool level, the appliance level, then you come up with these inconsistencies. But it is possible. We are helping companies today. This is active today, where we're helping them imagine how a very deep edge domain appliance becomes seamlessly compatible with back-end office tools like a NetSuite or others, that are available in the market. So I would say, yes, compatibility is built into the system's architecture if it's designed the right way, and the seamless migration of data back and forth between multiple tools is always possible.
Yeah, and I'll just add one more quick thing in that today there's a methodology, like we're probably a lot of familiar with DevOps, right, from a development standpoint. But now there's DataOps, which is a methodology to kind of get data moving around. It's really fundamentally around the concept that we have to have that standardization, that normalization, and being able to freely bring that information between these different systems, but with the right context. So it's starting to take a lot of steam today, and a lot of products and tools out there that help with that methodology.
Yeah, I think just one more point, Patrick. Around these ideas of products like NetSuite, basically what you're talking about is technologies that run on server, environments. These are installed and deployed on server environments, and so when we talk about the edge is just a scaled down data center environment in the forward context. But then what it has is this unique ability to talk to the OT world on the southbound side, so to speak, and the IT world on the northbound side. So if your edge compute continuum, your edge compute, environment is built to seamlessly marry into the OT environment, the IT environment, then that architecture matters. And what Intel has begun talking about is what we call the digital transformation enterprise architecture. It's not just about building an edge domain that can talk to a IT or central business domain. It's about actually integrating the path across those two domains so that it's seamless and it's seen as a natural continuum of computing, analytics, and data migration in order to support the needs of the business.
Absolutely. And of course, our machines at the edge, we would be there to collect that data and then allow the systems, to then do their work get that data into the location that you need it to make those actionable insights or to have that visibility over it. So yeah, it really, it's that continuum approach that I really appreciate about what you're bringing here today, Rick. And that actually goes into another question here, which is, when is edge computing not enough, and what functions still belong in the cloud?
It's interesting because we're going through that right now. I think, you have to look at the things that would drive, a need for a stronger edge compute domain. We look at things when we're talking with companies. Cost is a big one. Moving and migrating data from edge to cloud and back again can be costly, especially if it's off-prem and it's got to come back on-prem. Latency is a big issue. We're seeing that in our own factories, where sometimes moving data off-prem and bringing it back on-prem just doesn't happen fast enough for what the tools need to do, or what the workers and what the worker augmentation schemes need to look like. Bandwidth is a big one. Again, you start moving petabytes of data from a factory up into a cloud, and just the amount of bandwidth you need to be able to support that and have it actually think about an autonomous world where that would have to be fully autonomous. So I think, as you look at these ideas of cost, latency, bandwidth, interoperability, and then the last areas are security, right? I mean, just the thing that you open portals to your organization and you, open up the opportunities for cyber threats, cyber attack, and, IP security leaks. I think these are all issues you got to look at it when you talk about when the edge is more important than the core or the cloud. And so I think it's important to remember that the edge is not unlike the cloud. It's not unlike the core. It's actually designed to be, architecturally identical to those environments. So in truth, the edge can grow to be as big as you need it to be, or as small as you need it to be, in order to meet the cost and operational requirements of the business, and it scales. So again, back to the point of, what can go wrong. It comes down to operational efficiency. It comes down to security, cost, bandwidth, all these issues of when you grow your cloud versus your off-prem cloud versus when you grow and affect your on-prem cloud. And I think these things are not separate domains. They have to be viewed as an integrated set of technologies.
Yeah, I think it really looks at a balance between the two, right? You have to look at the business requirements you have for the edge and understand, what you would need there. There's maintenance considerations as well, right? With anything that's on-prem, there's less maintenance, if you will, in the cloud, and overall we still have to do all of that. But that balance has got to be important as to how do we solve what we need to do locally, as well as how do we bring in the cloud to augment that and have everything work together in that continuum that we're talking about.
Absolutely. Well, I think that wraps us for today. Thank you again to Rick and Travis for joining us. It was really our pleasure to have you.
Thank you so much for having us.
Absolutely. And to learn more, you can visit us at onlogic.com, inductiveautomation.com, and intel.com. So to the folks watching, thank you for joining us for OnLogic Live, Edge of Tomorrow. That wraps up our live event. So to take us out, we have a bonus Tech Edge video by OnLogic design engineer Hans about the latest generation of Intel processors, featuring a preview of our new Helix and Carbon systems. So we'll see you on next time on OnLogic Live. Hans, take it away.
Hey, welcome to Tech Edge by OnLogic. I'm Hans, and today I'm bringing you my highlight reel for Intel's new Elkhart Lake processors and why I'm excited for them. If you just so happen to live in Elkhart Lake, Wisconsin, you might have been surprised to find your small town in the news a lot over the last few months, all related to something called the Internet of Things. The uptick in press coverage is thanks to the latest generation of Intel processors, actually, which was codenamed Elkhart Lake during development. Today, we're going to break down some of what's neat about Intel's new CPUs and why they're an important part of the future of IoT computing. So, first things first. Intel uses code names when talking about products and technologies that are in development, before they're commercially available. They do it with every new processor generation, and Elkhart Lake is no exception. The proper name for these new processors is the Intel Atom X6000E and Pentium and Celeron N and J series. so you can see why there's an interest in continuing to refer to them collectively as Elkhart Lake. Okay, highlights. What's particularly special about these new processors is that they have a number of integrated IoT features, real-time performance capabilities, remote manageability, security, and functional safety, which have all specifically been built in for use in IoT solutions. That intentional design is an exciting step in itself for both IoT developers and solution providers like OnLogic. It gives us new tools to develop systems to solve technology challenges in automation, manufacturing, smart agriculture, and other fields that are seeing incredible growth as technology advances. It's also an indication that Intel is really putting some muscle behind IoT, and that's super cool. In terms of hard specs, Elkhart Lake provides up to a 1.7x improvement in single-thread performance and up to a 1.5x improvement in multi-thread performance over the previous generation. There's also up to a 2x performance improvement in graphics alone from integrating Intel UHD. That means you can drive up to 3 4K displays simultaneously, and that's something that was previously reserved for the Intel Core processor family. For our part, we're integrating Elkhart Lake processors into 2 new hardware series, and like those processors, they're specifically engineered for IoT. The new Helix 300 and Carbon 400 take everything that makes Intel's new Atom, Celeron, and Pentium processors special and wraps them in our hard-shell fanless enclosures, creating devices that can stand up to any environment. You can find out more about Elkhart Lake processors and our new Elkhart-powered systems on our website. Links below. If there's something you'd like to know more about or think we should cover here at OnLogic's Tech Edge, leave a comment below or drop us an email. And be sure to like and subscribe for more technology news and updates from the team here at OnLogic. Thanks for watching.